Parents have taken away from us to he's actually so pretty good he's already got his features cut out for him. His parents are both investors. More than likely what's going to happen is he's going to teach him how to invest his college fund.
Well, if you're not going to go to class, I mean, if you're not going to go to class, going to college is kind of ridiculous. So, well, that's better than blowing it on.
I know, right? You don't have any loans.
All right. Hopefully this works. All right. YouTube changed the way it does live streaming. It's changed it 3 times this week. So, unfortunately, it's going to look a little bit different today than it normally does, but hopefully it looks the same on your end. All right, so what's on your test? If you are joining us live on the web, the first thing is Riemann sums. You have to do the left-hand rule, the right-hand rule, the midpoint rule. Also, because you get to suffer like people suffered, we did take the skill quiz on the limits one today. Make sure that you also, Nothing. Make sure you also take that before you take off for break. The next thing that's on your test, antiderivatives, like the integral of x squared dx is equal to x cubed over 3 plus c. Why do we need the plus c again? It's always constant of integration. There could have been some constant in there whose derivative is this answer. Fundamental theorem of calc tells us 2 things. The integral from a to b of f of x dx is equal to the antiderivative evaluated at b minus the antiderivative evaluated at a. P.S. Those of you on the internet watching this, you really owe Laura Miller. I wasn't going to record this today, but she wanted, out of the niceness of her heart, not mine, hers, for us to put this on the internet today. So, third thing, if you take the derivative of the integral from a to x of f of t dt, that's equal to f of x times f prime of x. We're going to do one of those because Dylan asked me for one of those. Fourth is the average value. The average value is equal to 1 over b minus a times m. The integral from a to b of f of x dx. Last thing on your test is the acceleration velocity position of the particle problems. Net displacement is equal to the integral of velocity. That's just how far you are from where you started. And the total distance traveled is equal to that's absolute value. Now, that does mean you have to break those up. So the rest of today, the next half hour, what are we going to do? We're just going to explain problems. I'm going to see if I can zoom in here too. Nope, that doesn't work. Because YouTube's changed its settings on the live. I think they're trying to come out with a new one. They're just putting it in beta out there first. So it looks totally different than it does before. And it just came up looking like this. The camera on my laptop is recording me right now. Yeah. Yeah.
Oh, so
all right, so let's take a look at some problems here. And actually, I will how am I going to do this? We'll take this desk and do it. Hashtag problems. All right, Dylan asked for a second fundamental theorem of calc problem. So let's look at a second fundamental theorem of calc problem. Yay, let's look at that. And that's kind of, well, it's got the glare, but I can't do anything about that. All right, let's take a look. Easy one or nasty one? Why not? Nasty. Example number 1 of things that could appear on a test that you'd see on Thursday. The integral, the derivative of the integral from, where should we go from? 0 to, I don't know, 3x squared plus e to the 3x. Nope, we don't know how to do that yet. E to the x. Jane, that's a U sub problem. That's the first thing we do when we come. Actually, that's not true. We do a mean value theorem, and then we do that. Well, let's go nasty. All right. I like green. It's like writing everything in highlighted. Bet kids in Iran don't complain like this.
Then you're going to leave a comment and say, yes, they actually do.
No, they're going to be like, I'm scared to even ask questions in class. One guy asked if he could, one guy asked, and then the Supreme Mullah came and took him away. So the people in Iran that watch this video will get that joke. All right, so here's the weird thing. On this one, we have to take the derivative of a what? The derivative of a what?
Consti.
The derivative of a integral. What undoes an integral? Derivative. Now, normally it works out very nicely because this thing up here is what? No, it's usually x for these problems. It's usually x, which just means then we put an x everywhere there's a t in this puppy. That doesn't work for this because we've got a function up there. So what do we have to do? We have to use a u sub and multiply by its derivative. We have to use a u sub and multiply by its derivative. So what do we let u equal? The top endpoint. Okay, real quick, what's the derivative of this then? Okay, stop and check out. Questions on that?
Do we need to use the u sub or
You don't have to. I don't use u sub on these, but that's like the method we do for this. Like until we get more comfortable with like just taking integrals over and over again. Like at the start, we actually broke up derivatives and took each part, and then by the end, you can just look at it and know what it's equal to. All right, so there we go. So what do we have to do? We're going to use a u sub, and don't forget this is also multiplied by dx. So what are we going to do? We're going to use a u sub and change this in terms of u's. So we're going to go not from 0 to this, we're going to go from 0 to u. Same thing in here. E to the 70. Guys, I can't think if you're talking. That means stop talking. Okay, but now we've changed it to u. So we got to do two things. We got to change the front to d du. Well, how do we make that work out? So d over du multiplied by something has to be equal to dx. Du over dx, right? Du over dx. So what do we put at the end? We have to multiply by this, du dx, which conveniently, how do we get du dx? We just divide both sides by dx. So what have we done? We just changed it to u, which really means we just have to multiply it by the derivative of what's up here outside. What's the mechanics behind that? We switch it to u's, which means we switch this to du, which means this needs to be out here. Now, real quick, we notice if we took du times du dx, we get what was up here. So again, we take du times du dx, we get what was up here, which takes us back to the original problem. Okay, so let's do the mechanics on it. This is just a second F fundamental theorem of calc problem. This is second fundamental theorem of calculus. So all this is this function evaluated at this endpoint. So the square root of e to the 7u plus u squared. But then we need to multiply by du dx, which we conveniently already found was equal to parentheses 6x plus e to the x. Question, plus c or not? No, because it had what? Endpoints. It's a definite integral. It's a definite integral. Last thing, we replace the u's with what it's equal to. So this is equal to the square root of e to the 7 times 3x squared plus e to the x plus u squared. U is equal to 3x squared plus e to the x squared multiplied by 6x plus e to the x. The only difference between this and the easier ones is you're multiplying by the derivative out here, because you'll notice what's in here looks just like a regular second fundamental theorem of calc problem. It just becomes a chain rule because you have to get what's in here out there too. Sorry, I did go way low down there. You can move, that's fine. I'm not going to beat you. Napur, you know this is about your learning. In theory, I already know how to do this. You hope. All right, so that's the second fundamental theorem of calc problem. That's a nasty one. Now that's legitimate, like that's an AP problem. That'd probably even be on the free response, not the multiple choice, because that's nasty. But yet we are smart enough to do nasty ones now. In fact, that's probably one of the harder problems in the entire integrals unit, like chapter 5 and the whole thing, even when we go finish it after spring break. Yep.
What time is the AP test?
I believe it's 7:30 in the morning, but Mrs. Hutch does come back one more time this year and like give you the you need to be there spiel.
Do you know if she's now Miss Hutch to Gone and
Oh.
Karachi?
No, it's just Miss.
Miss Hutch
Um,
to Karachi.
Yeah.
If there is a makeup date, because the juniors that are in graduation,
Is that the morning of grad practice?
the test is the morning of grad practice. The makeup is like May 25th. Alyssa,
Yeah, definitely.
who's the person in front of you in alphabetical order in your class?
Probably one of the stoners.
Follow them.
Do you judge, get caught, all that stuff? Follow.
Seriously, here's graduation practice. Go in front of the person in front of you. Follow
What
them.
if I'm like the first person, right?
Bochelle is not first in
The
alphabetical
person
order.
in my row, like.
You just, when they run out of seats, you go to the next row. But here's the good news. The junior escorts are the ones who actually like get the, and okay, and listen, just so you know too, how many of you were junior escorts last year? How many of you got the updated sheet of paper with the newest seating chart right before graduation started? Because always there's somebody who's like on the borderline of graduating, so they let them go to graduation practice, but if they don't actually make it, then everybody just gets adjusted one seat. So
I hope I sit by someone that's fun.
if you're on the end, you get to sit by one of the teachers. I think me and Mr. Breebach are always fun to sit by because we take the knives to the volleyballs you bring.
That
The
was
beach
so
volleyballs.
funny.
So, no, what was funny was you all seeing Cheryl chase after all of
Yeah,
them.
that was.
That was funny. Other questions on this one first? Other questions on this one first? Mackenzie, you were next, then Medusa after that. Oh, yes, Napur. And Napur.
Sorry, I'm not trying to like. I genuinely want to.
Kayate. If you want to talk, go out in the hall. I'm not going to be mad at you. Just don't talk when people are trying to learn. They're trying to cure cancer. It's going to be hard. They got to get used to working hard problems. Yes.
Okay, I would like to know a real life application having two variables in like the same. I'm sorry, I like genuinely.
Okay, so here's the real life application for this. You're in a calc class. They give you a test. It happens to have a problem that looks like this on it. You have to solve it. No, there's
You're not gonna give us a word problem.
no, there are no word. Well, that's not true. There are word problems for this that have imaginary numbers in them. And that's the real life application for that. There's this whole class called complex analysis that you do everything in calc with imaginary numbers. And this is actually how we find the imaginary, okay, if your parents are electrical engineers, please do not quote me on this. I did this 15 years ago when I took this class and then promptly forgot it about 8 seconds after the class was over. This is the method that we use to get the imaginary coefficient of the amount of power generated by a turbine that does not come out of the real coefficients. Say that to yourself 3 times real fast. If you can't fall asleep, you're not going to. So, yes. So that is the real life application of that. There is not a real life application that involves this in this class. Now, they could put this as you have to find the area under a curve and here's your profit equation. It just happens to be that, but there's no actual like real life application for that. Sorry. Sorry, internet. Other questions on this one? Call tough.
So basically, you just like set it up and then substitute with you and then just put what you read.
Yeah, I have the feeling like we should work one so you can validate you're doing this right. Is that a
Yes.
good feeling?
Yeah.
Okay, let's give you nasty or okay.
Okay.
Okay, let's go for nasty. Let's go for nasty. Let's go for nasty. Example number 2, straight off the internet. The derivative with respect to x of the integral of, oh, let's make it a little bit nastier. Let's go for 6x cubed minus 3 sine x
Yeah.
to 4 of all right. Question. The dirty trick on this one is we've put the function that's in the endpoints in the what? How do you move it up to the top? Yeah, you make it negative, right? You make it negative. So let me say it when you guys stop talking. Because I do a really good job of teaching you guys, but I can't do it while you're talking. So this can't be here. Second FTC only works when this is up here. So we need to switch these endpoints. How do we switch these endpoints? Yeah, by bringing a -1 out front of the entire thing. Like outside of the derivative, outside of the u, bring it out front of the entire integral. So that's your first dirty step on that one. Ready, set, go. By the way, Napor, did you get a trophy back?
No.
Okay.
I think I'm going to go down tomorrow and talk to King. Did you make it?
Okay. Somebody stole it.
Go.
They work in the They're our principal. It's a long story.
Where, if you like win state, do you know the nationals for debate?
You do not have to, actually, it's kind of weird, they're totally separate. So it'd be like if there's a national basketball championship and a state basketball championship, they have nothing to do with each other. Like there's different tournaments. So Napor is going to both, but they're totally independent of each other.
Florida.
Yeah, it's in Fort Lauderdale this year.
When is it?
June 16th through the 23rd.
Oh, it's part of the summer.
Yeah. Yeah. Yeah, and we've had teams from our area. Like we had a World Schools debate team that finished 7th in the whole country last year. Saxon Bryant from Pueblo West finished 2nd in World Schools debate as an individual in the entire country, actually in the entire world last year.
Do you think that you guys are going to do well?
I think Napor's message will be much better heard once she gets out of Colorado.
Colorado Springs.
Napor knows this, so I can say this because I've told her probably a dozen times, but I'm shocked she did so well in Colorado Springs because I didn't think her message would be very well received.
It's like overpopulation and the importance of contraceptives.
Just for fun, can you just give us the first 2 lines of your speech?
So I asked my principal, can I throw condoms at my class? And he said no.
Yeah. It's a really engaging starter, like really gets the audience attention.
Wait, can you give us your speech, please?
It's on the internet somewhere. Yeah, it's really good. Just sometimes you get people who can't hear your message no matter how well you say your message because they disagree with it. And
Did you actually ask?
If you start with that, you
I
have
asked
to.
Dave that, and then I asked Papa that, and they both said no, so.
And I'm sure they're just looking at themselves going, I'm gonna be on Fox News. I'm gonna be on Fox News.
It's probably effective.
Alyssa, this is the first district that I've worked in that they did not teach that. Like in Washington State, you get a very thorough education in that area. Well, that's debatable. And let's just say Napor wouldn't have her OO if they hadn't said no to her. So it was a good deal for Napor. All right, finish it up and then we'll go on to another question. Finish it up, we'll go on to another one. Who's already got it right? Who's already got it right? Is that what you're reading? What else are you going to do in Senate class when you're done with practically everything for Senate?
I have to send you.
Well,
We have bonding days every Friday. Hey, you're invited to attend
I could totally
Friday,
see
Friday, February 13th. I mean, it's Friday. I can see it.
Right.
That'll be nice. So, excellent. What is this? Is this back?
you can go ahead. Napor, I've already heard it like 30
I
times.
know, I just tell
Always
her.
just making faces.
Basically, reduce population growth rates by like just like crazy. And my dream is, so he has a TED Talk, and like my dream in life is like to get a TED Talk with him. That would like be, that.
Her dream
that
is to
would-
go to senior assembly, handing them out to everybody.
It's senior kid.
Is that on the internet?
Yeah.
I'm gonna ask you about that.
I just-
don't know if we can do that.
Oh my God.
We all had to wear caps the week.
Oh my God. All right, let's go back to this.
Oh, I wanna ask you.
Oh, okay, hey, let's go back to that. Let's go back to the math. Oh my goodness. Just imagine the horrid look on Hatchel's face.
Did you get in trouble for that?
I don't know what I.
Only
they
you
make
got
you-
caught. So.
All right, let's go through. Volunteer to come up and do this one.
Don't worry, it's just there.
Oh, Bochelle, come on down. Yeah. All right. First thing is I have to put that negative out front. So I'm going to do that first. The negative and then this.
Yeah, then everybody.
Okay, so first thing I do is negative the whole thing. Next thing, I set the u equal to what's on the top, so 6x cubed minus 3 sine x. Okay, take the derivative. What's the derivative of this puppy? 18x squared, good. Gotta stop talking unless you're helping. Minus, what's the derivative of 3 sine x? 3 cosine x, right. And then the whole thing is multiplied by what? dx, right, because then you just move it over here to get du dx, which is what we're going to have inside that integral. Okay, now I know some of you watch videos from other people on the internet. They just magically put it there. Okay, I do want to show you where it came from because we did take the derivative of u and we took all of this with respect to x, which is how we get the du dx over yonder. Yep.
And do we have to do that step or can we just go straight to do?
If you can, okay, somebody asked this earlier, like, do I have to show all these steps? The more you do this, you just realize what you have to do. Sort of like when we started taking the derivative, like if you had to take the derivative of 6x cubed, you said, okay, 6 times 3x squared, but now you just know it's 18x squared. If you just know it, that's fine. You don't have to show this work. But Mackenzie, I always show more work teaching than I do doing because I don't want people to like not follow what I'm doing. Because in theory, I already know how to do this. In theory. Okay, so let's then evaluate. So then this is just a second fundamental theorem of calc problem. So I get negative d du, integral from 4 to u of, bless you, e to the t plus 7 to the t dt. Then multiply the whole thing by du dx. This, just second fundamental theorem of calc, so I put u in. So this is equal to negative, don't forget there's a negative out front of the whole thing. Negative, plug in u, so this is e to the power of 6x cubed minus 3 sine x plus 7 to the power of 6x cubed minus 3 sine x, 3, all multiplied by multiplied by du, which is 18x squared minus 3 cosine x. Small detail, do make sure you have the parentheses in so they can follow what's being multiplied by each other. Do you have to multiply that out? No. Could you set that equal to 0 and solve? Yeah, would it be fun? No. No, that's why you buy the calculator that does it for you. Josh.
So the 4 literally means nothing else.
Nothing. And that's the weirdest part, because if you actually took this integral, it would be, sorry, internet, big F of u minus big F of 4. Big F of 4 is a constant. When you take the derivative of a constant, it goes away, right? So literally, it has nothing to do with it, because when you took the derivative of that constant, it just went away. But it,
Wait, is there going to be one that has like 2 functions on A and B?
no, doesn't work. Only works with those top, there's a function on the top.
And
Yep.
can I just write the answer because I did not do any stuff?
Yes,
Just the answer.
that's fine. Now, you're living dangerously, but yeah. Other questions? All right, let's take a net versus total displacement problem. Let's go for, hey, I gotta come up with this real quick. I gotta come up with this. Okay, that does what I need to. Can I erase it up here?
Yeah.
Okay, internet, you can pause. Here we go. Okay, example number 3. A particle is in nonlinear motion with its velocity equal to, what are we gonna have? 3t squared plus 12t minus 15. And they ask us to find us for 2 things, from 0 greater than or equal to t greater than or equal to, what are we gonna have? 1, so let's go to 3. What is the net displacement? And what is the total distance traveled?
Is there a calculator problem?
No, this is not a calculator problem. Because it made it work out really nice. That's very few life issues. Checking my email to make sure Mr. Bailey hasn't emailed me about being fired.
How did you get fired?
Napora's graduation plan.
He's like, I heard that. I've been
What's
watching
that?
you. Need to leave.
Can you not?
You could.
Well, yeah.
Private.
I don't know if it heard it because it doesn't seem to be picking up anything when I'm behind the computer. Because usually I have that goes 360, but this only goes this way. So
Yeah, dude. I heard it's.
what are you worried about? You're not going to get fired. Just get your mission to. Oh, thank God. You look like Bailey for just a half second. All right, so net displacement. I'm going to set it up and let you do it because I know you can find this one. This one is a little bit more work. So the net displacement is just equal to the integral from, we're going from 0 to 3, 3t squared plus 12t minus 15 dt. I'm confident you can take that integral, you can evaluate it at 3, you can evaluate it at 0. The difference between the two is what you have to do. The difference between the two is what you have to do. Shottery, here's your quiz.
Is that all?
Well, you have to actually like compute the answer, but yes. Now, total distance. Now, the problem is if it's going to the left and then it changes and goes to the right, those do what to each other? They cancel each other out, right? Because the positive and the negative add to 0. To find the total displacement, you have to figure out where it's negative, figure out where it's positive, and take the absolute value of its value. So what do we have to do with this? First thing we're going to have to do is factor that to figure out where it goes from positive to negative. So I said 0 equal to this. The first thing I noticed is I could take a what out of all of them. Right, so I do. Okay. What does that factor to? Yep. So where are the 2 places it crosses the x-axis at? Okay, the only one we care about though is what? +1, because that's the only one in between here. And here's the question I have for you. It crosses at 1. To the left of 1, is it above the x-axis or below the x-axis? To the left. And we also know there's 1 at -5 too. here, is it above or below to the left? Below, because the A is positive, it looks like this. So it's going to cross twice, once here, once here. So we know between 0 and 1, it's negative, and then from 1 on to forever, it's positive. So here's what we have to do. I'm going to set up the integral and assume you can do the integral itself. So I'm going to sin and come over here. So this is equal to the integral from 0 to 1 of 3t squared plus 12t minus 15 dt. But this is going to all return what kind of numbers? No, negative, because this area under the curve here is negative. How do I make it positive? I multiply by what? Right, so I'm just going to put the negative in front. That's what the absolute value does. If it's negative, it multiplies by -1. If it's positive, it just keeps it as is. And then I'm going to add the integral from 1 to, where do we go to? 3? Of 3t squared plus 12t minus 15 dt. I assume you can find that integral. You can plug in 1, you can plug in 3.
Yes.
So you have to figure out where is it negative. You have to evaluate it separately where it's negative from where it's positive and multiply where it's negative by -1 so that it does not cancel out the distance there. Now, stop real quick. Which one number is going to be bigger? Net displacement or total distance traveled? Total distance traveled. Is it possible for net displacement to be negative?
Yeah.
No,
Displacement is just the movement.
Net displacement could be to the negative. That means it ended up to the what? The left, right. Is it possible for total distance traveled to be negative? No, that has to be positive. That has to be positive. If somebody says the total distance I traveled today is -30 miles, they've used some sort of drug. All right, have a good day.